This is question number 19 of GATE 2018 Metallurgical Engineering. A long oil pipeline made of steel is suspected to have developed a scale on the inner surface due to corrosion. Which of the following non-destructive testing or techniques is the most suitable for detecting and quantifying such a defect? Option A, dye-penetrant testing. Option B, magnetic particle inspection. Option C, ultrasonic inspection. Option D, acoustic emission. Right. So for understanding all these types of testing method, you can refer course on Theory and Practice of Non-Destructive Testing by Professor Ranjit Bori from IIT Madras. So we will go from option A to D and understand whether this method is capable of detecting our scale on the inner surface due to corrosion or not. So the dye penetrant testing is basically a surface entity method which is capable of detecting only those defects which are open to the surface. Like some crack is present on the surface and that crack is open to the surface, then we can use this dye penetrant testing for our defect detection. So this method basically cannot detect inner surface defects like scale formation. So this is not capable of detecting formation of scale in the inner part of your pipeline. Coming to the magnetic particle inspection, so it works basically on the principle of magnetic flux leakage, and that flux leakage basically attract the magnetic particles and indicate the presence of defect if so. So this magnetic particle inspection is a surface NDT method, sometimes subsurface also, but mostly surface NDT techniques only. So this is also not capable of detecting presence of scale in the inner part of your pipeline. Coming to the ultrasonic inspection, so yeah, this ultrasonic inspection can be used for both surface NDT method as well as bulk NDT technique or internal flaw detection. So here what we do is we basically use very high frequency sound waves around like 1 to 15 megahertz, and these sound waves will be traveling through your material, and if some defect is present it will be reflected back, and we will analyze the signal which we sent and the signal which we are receiving, and by that we can have like at what depth some defect is lying, or what is the length or what is the size of that defect. Even we can have the thickness calculation of that material, because if we are sending sound wave, it will be reflected back from the back wall, that is internal wall of the let's say it's pipeline. So it will be giving back wall signal as well as the first wall signals, the front wall signals. So from that we can have a calculation for thickness of the material. So if some scale is forming and if this scale is eroded by your let's say oil traveling through your pipeline, so there may be some thickness reduction. So we can have thickness monitoring using ultrasonic inspection, and that inspection will be capable of detecting corrosion happening inside your pipeline. So ultrasonic inspection is suitable for this type of detection. Coming to the acoustic emission, so what will happen in acoustic emission is basically if some defect is present, let's say a crack is present in your material, and your material or component is subjected to a load, right? So presence of load and defect, whether it's internal or external, so this will cause an emission of transient elastic waves. So elastic waves will be coming out from your material from that particular location, and the detection of this elastic wave will be like that elastic wave will be analyzed, and your defect can be detected. So it's used for like local presence of any defect, right? But coming to the our case, so for a scale formation, among all these four, ultrasonic is the best one. So acoustic emission we cannot use for a scale detection inside our pipeline wall. So the right option for our problem is option C, ultrasonic inspection. Thank you.